BambuLab ASA, good material, great for outdoor applications, but if you add some carbon fibers to it, will it be even better? Welcome back. BambuLab is creating new filament types faster than I can test them. This is ASA reinforced with carbon fibers, and with this filament I will repeat that regular testing method, so the results will be comparable with those which I did in earlier videos. And later in a separate video, because even I'm a little bit confused, I want to compare ABS, glass fiber ABS, ASA and carbon fiber ASA in a same video, and I already have these four filaments in black color. And there I will have a little bit different testing methods because I want to compare them a little bit better to see, for example, which is the best for the worn parts. What is the dimensional stability compared to the carbon fibers or non-reinforced filaments. And also I will test, stress relaxation and similar. But let's go back to the carbon fiber ASA. Usually ASA have very similar mechanical properties to ABS, only it is UV resistant, and carbon fibers helps they increase the stiffness and dimensional stability. And compared to the regular ASA, which has the shiny surface, this version will have the matte surface. And according to specifications on the website, even the layer adhesion is improved with carbon fibers, which is surprising to me, but we will test this too. And according to specifications, it required hardened steel nozzle. 0.6 mm is recommended, but it should work with 0.4 mm, and this is what I will test. And also they have the information drying 80 degrees Celsius 8 hours. This sounds a little bit much. ASA is less sensitive to moisture compared to the nylon or PETG. At this point I'm not sure. Usually I test these filaments out of the box, and probably I'll do this here. The price is $37 for 1 kilogram spool, and it is available only in black color. Maybe it is important to mention that I got this spool from the BambuLab, but I'm not paid anything above this to make this video. And this is the case with my every filament testing. Well, actually not, because sometimes I buy the filaments myself, but from more than 400 videos, only one was sponsored, so definitely I'm a very bad businessman. And maybe you didn't even notice, but the mid ads are again disabled on my channel. Let's see what's in the box. Information on the box: the print temperature between 250 and 280 degrees Celsius, but I will use the default settings in the Bambu Studio. And this packaging is definitely much better than that regular foil. It protects much better the spool from the moisture. And also pay attention that this bag is resealable on one side, which is smaller compared to the other. Let's see how brittle is the filament. Oh yes, very brittle. BambuLab ASA carbon fiber, it's in the list, confirm, load. The printing will be on X1 carbon, and I already placed the spool on the back side. And because ASA may have some unpleasant smell, my X1 carbon is connected to that exit on the wall. I will use the engineering plate with the glue on it. And since I got these filaments much earlier before the publication, at that time there was no profile for it. So I'm using only the ABS glass fiber profile, only I'm changing the temperature to 270 degrees Celsius. First layer inspection, but it's absolutely perfect. Last few vertically printed test objects. I can feel the smell of the ASA, I even increased the exhaust fan. Perfectly straight objects, no sign of the warping. Perfect. Ready for mechanical testing. Carbon fibers usually helps with dimensional accuracy. The design dimension here is 80 millimeters, and in this case it is 7984, and without carbon fibers it would be 79.6 millimeter or smaller. Tensile test, and I'm starting with horizontally printed test objects. These are the average values from these two numbers. And now the layer adhesion test with vertical printed objects. A little bit weak. On tensile test average values for the ASA, but on a layer adhesion this is a little bit weak. According to specifications this should have much better layer adhesion. I will reprint these test objects, but now on 280 degrees Celsius, and I will completely reduce the part cooling. I'm not even sure if these overhangs will be printed at all. Beside the test objects, I will print at these 6 dies, so the layer have more time for the cooling, because the temperature is 280 on the nozzle and absolutely no part cooling. And this is just short preview in the Bambu Studio. Actually, this came out quite good, not perfect, and interesting matte surface we have here. But as you can see, it is very close to the failure, so it was printed correctly, but I couldn't go much higher with the temperatures. This was significant improvement. Maybe it deserves a separate video to see how much higher can I go with the print temperatures. Two-sided shear stress with the horizontally and vertically printed test objects with the same dimensions. They are shared correctly in 3 pieces, only it is hard to find smaller black pieces on this surface. Printed horizontally very strong thanks to the carbon fibers, but printed vertically, well, we have the weakness of that layer adhesion. Torque or twist test with horizontally and vertically printed test objects with the same dimensions. 1.1. Very often I can see similar numbers with horizontally and vertically printed test objects, only these usually break more suddenly. 3-point bending test, and I'm placing these loads and I'm measuring the deformation after 1:30 and 60 seconds. And this is a speed up time-lapse video. Deformation after 5 kilograms, 10 kilograms. And after this test I can see some permanent deformation. Not much, but it is visible. Temperature test in the oven, and this is carbon fiber ASA from this test. These are some nylon filaments, completely different category in this kind of testing. This is speed up time-lapse video, and this carbon fiber ASA started to deform on a little bit higher temperature compared to the regular ASA. It started to deform at 101 degrees Celsius, and on 150 I stopped the experiment. The surface quality is nice, but of course it is deformed a lot. Impact test with this half kilogram hammer, ASA-CF. 0 position. And now let's check the numbers. Compared to the average PL or PETG material, the ASA-CF is tougher, but compared to the non-reinforced ASA material, this is much more brittle. The creep tests the deformation under the constant load, and I have several tests in the progress with different materials, so it will be a good reference. Very minimal deformation. I am measuring the distance between two reference surfaces, 13.54. From all these materials, these have the smallest deformation, but we will see what will happen after 5 days. But I will measure them every day. This is the last 5th day, and the smallest deformation I can see on this carbon fiber ASA. 1364. And now let's remove all loads. I already measured it. Immediately after I removed the load, it got back the original shape almost without any permanent deformation. And now let's see the results, and this Excel table you can download from my techfun.com website, and this one line will be added to that summary table for my Patreon supporters. But for this video to be more interesting, I will include the ASA results from one of my previous videos. Here you can see some print settings data, but let's start with the creep test. And this is the distance between two reference surfaces, but what we need is the difference between 2 days. And we can see that the ASA-CF stopped with creeping even on the first day, until the ASA stopped with this deformation under this constant load maybe after 2nd day only. On a tensile test, the ASA-CF is slightly better, but the difference is not big. On the layer adhesion test, in first attempt, the ASA-CF is very weak, and this is what will be added to that summary table for my Patreon supporters, because it was printed with default settings. If I raised the print temperature and completely disabled the part cooling, then I got very similar results like with the ASA. On shear stress, ASA-CF is stronger compared to the ASA. These are horizontally printed test objects, and at that time I didn't do vertically printed test object. I started that later, and this is the result for this ASA-CF. On 3-point bending test, here we can see the deformation under these loads after 30 seconds. Smaller values are better, so definitely the carbon fiber ASA is stronger, stiffer in this test. But this is more interesting because here we can see these deformations after 1:30 and 60 seconds. And not only the carbon fiber ASA is stronger, smaller deformation, but also under 10 kilogram load, look at this. This is more horizontal, so less deformation during the time compared to the regular ASA. On torque or twist test, this is the load at 90-degree angle with the horizontally printed test objects, And interesting, the ASA was slightly stronger here. And also I have these vertically printed test objects, but again, I have this only with the CF version. At that time, I didn't do with the regular ASA. And on the isot impact test, huge difference here. So this is very tough material, the regular ASA, and the carbon fiber version is very brittle compared to this one. On the temperature test, no surprises here. Those carbon fibers always help here, and it was slightly better compared to the regular ASA. And maybe interesting data is the shrinking, and this is again typical for these carbon fiber filaments that they have better dimensional accuracy, less shrinking. Few times I got the comments that you don't know how to use this data. But first of all, you have to recognize the stress types in your application. For example, I have this lamp holder, and with this at least I can record at night, because next to my own family members it is hard to record during the day. And it is fixed to tripod using this clamp, and it is fixed by one screw only, and sometimes it rotates around it, and I need some better solution here, but I can use only one screw, and the friction is not enough sometimes. So I printed this part from this ASA-CF, and I know that we withstand the bending and also the creeping, because if I tighten it, I want it to be fixed there, but the layer adhesion is not so important here. And already tested it, it works perfectly now. Conclusions. Well, more or less what I expected. When I was curious how much weaker will be that layer adhesion, but maybe thanks to these carbon fibers we can compensate it with printing on higher temperatures or reduce the part cooling and similar, because with this version, with carbon fibers I can do it, but with the regular version of the ASA I couldn't go much higher with the print temperatures. Another disadvantage is that this is more brittle material compared to the regular ASA, but it is stronger, stiffer in X and Y direction, less scraping, better resist to the bendings, and more temperature resistant material. And this is why I included that example a few seconds ago, because you have to recognize the stress types in your application, and then you can choose the correct material. About my future plans, I already mentioned those 4 black filaments will be compared in one video, and guess what arrived? PPS CF, but it requires 310 degrees Celsius or higher, so I have to wait until I finish the +4 kiddie 3D printer assembling and review, or maybe I can try it on 300 degrees Celsius on X1 carbon in a short video, I will see. And also the TPU for the AMS is on the way. Also I have a message to the BambuLab, please slow down a little bit, because I cannot test your filaments so quickly how fast you are producing new ones. I have here at least 8 different brands filament types, wait for the testing. And maybe I should start accepting sponsorship. In that case I will have less work, but that's not me. Of course I accept Patreon donations, and don't forget to subscribe and click the notification bell button too, because in most cases the notification is not sent to my regular subscribers, only if you click that all notification bell button too. Not sure why, but this is the case. Anyway, thank you for watching, happy printing!